Okay, good morning. So I want to actually give you some examples that we can use these formulas, and then hopefully the lesson will be a short lesson. Okay, so I have written the formulas down here for you. This is the addition and subtraction formula for sine. This is the addition and subtraction formula for cosine. Okay, so let me start with an example. Show that sine of alpha plus beta multiplied by sine of alpha minus beta is equal to sine alpha squared minus cosine minus sine beta squared. So do you remember at some point we learned about trigonometric identities? Yes. Okay, now that we have new formulas at our disposal, we will be able to solve new identities. We will be able to prove new identities. So I want to show that for any choices of alpha and beta, the left-hand side is always equal to the right-hand side. So that is the topic of trigonometric identities, if you remember. Okay, and then I told you that usually if you want to prove an identity, it is better to decide on one side and start from that side and try to manipulate it a little bit so that you can little by little reach to the other side. Of course, there are some alternatives. If the problem is hard, you can manipulate the left-hand side a little bit, the right-hand side, and then compare the results, yes? Okay, but this is usually, yeah, I wouldn't say that is bad, so that's sometimes inevitable. But here, I will start from the left-hand side to the right-hand side. Because for the right-hand side, what can I do at most is to factorize it using the conjugate rule. So then it becomes sine alpha minus sine beta, because I have seen some students make this mistake, by the way. They start from the right-hand side and then factorize it. This part is completely okay. And then mistakenly they say that, okay, then they assume that they can factor sine out and then write minus this one. And then they factor sine out and write this one. And they think that they have reached from the right-hand side to the left-hand side. But of course, the first step is completely valid, but the second step is totally wrong. And I told you before, so the formula of sine alpha minus beta is not simply sine alpha minus sine beta, it's more complicated. So this is why this is not correct. So what I do, I will start from the left-hand side. Okay, I have this formula here, number one. So what I can do, I can replace this with the right-hand side of the formula, which is sine alpha cosine beta plus sine beta cosine alpha. Okay, and then you multiply it by this, which is the second formula. Yes, it becomes sine alpha cosine beta minus sine beta, cosine alpha. So what I have done, I have just started from the left-hand side, and then I used formula number one for the first factor. I used formula number two for the second factor. Okay, but then what is your suggestion? Well, how should I continue? Do you have any idea? Because, by the way, when you want to prove an identity, you should have always an I on the right-hand side. So your goal is to reach to second powers of sine alpha and sine beta. Might be that is helpful to see what to do, at least. Any suggestions? Yes?
Multiply them each other like the word parentheses.
You can multiply them, but simpler than that. Multiplication, if you do it in the exam, that's okay. But I want you to train your eyes to detect the pattern. So what pattern is this? Yes? It's a conjugate rule, yes? So I have a number, whatever it's here, it's repeating itself here. And this number is also repeating itself here. One of them has positive sign in between, one of them has negative sign in between, so that's the conjugate rule. Of course, if you multiply, that will also work. So then what I do, so I would say that the first one squared minus the second one squared. And then you know that if I have a product, if I want to raise it to power 2, I can do it separately. So I can say sine alpha squared cosine beta squared. And then minus, I will do the same thing here. So this becomes sine beta squared cosine alpha squared. So I think it's good because at least what you need is sine squared alpha appears and sine beta squared also appears. But there is one minor problem here. I don't need them, but they are there. I want to get rid of cosine squared beta. I want to get rid of sine cosine squared alpha. Because you see that I don't need them. So then what should I do? Of course, I cannot clean them. Life would be very simple if we could do that. Yes. So what can I do now? This is something that I told you before. Here, you want to get rid of cosine squared beta. But of course, you cannot just simply eliminate that. You have to rewrite it in a different way that you need it. So here, I do not need cosines, but I need sines. So it might motivate me to replace cosine squared beta in terms of sine squared beta. And if you think in that way, then it becomes easy. Because you would say that, okay, I keep this one because I need it. I see it, it is on the right. I eliminate cosine beta in favor of sine beta. So there is one way to do it. And then I would write 1 minus sine squared beta. This I really expect you to know very well. Okay, so if you want to replace cosine squared beta in terms of sine squared beta, this should more or less come to your mind immediately. Okay, do I need to change anything here? No, because I need it. And I want to get rid of it in favor of sine alpha. So then again, same strategy. Might be this still doesn't work, but this is one way to think about it, yes? So this becomes what? 1 minus, I have 1 minus sine squared alpha. Okay, and then what is your suggestion then? This is more or less the only thing that we can do after that. What I'm supposed to do? By the way, I hope that you feel this is a progress because what I need on the right is only sine alpha and sine beta. And what I have in my hand right now is just sine alpha and sine beta. Yes? You just multiply, yes. So this becomes sine alpha squared multiplied by 1 minus this term multiplied by that is sine alpha squared sine beta squared. And then I multiply this in, so it becomes minus sine beta squared, and then this becomes plus sine beta squared sine alpha squared. And then you see what happens, yes? The terms that I really don't need, they are actually cancelled out. Yes? And then what is left is sine alpha squared minus sine beta squared. And that is equal to the right-hand side. So we were able actually to prove this identity. Any questions? Yes. Okay, so for example, By the way, we talked a little bit about double angle formulas. Let me remind them here for you. So what was that? Do you remember in this formula, if you replace alpha with theta, and if you replace beta also with theta, then it becomes theta plus theta, which is 2 theta. And then you take sine. And then instead of alpha and beta, you just put theta and theta. So it becomes sine theta, cosine theta, sine theta, cosine theta. So if you add them, it becomes 2 sine theta, cosine theta. Okay, so I talked a little bit about this for you as well. So I would say that this is called the double angle formula. So if I have theta, double it, and take sine, it is not correct to just pull 2 out and write this part. You have to also multiply it by cosine theta. And if you remember, I also told you that you need to interpret it in a correct way. It doesn't mean that it should be only 2 here. You need to interpret it in that way. Whatever you see here, you divide it by 2 and put it here and there. Yes? So for example, if I ask you, what can I write for sine 4 theta? So it doesn't mean that you are not allowed to use this formula because instead of 2 you have 4. Yes, you can, but what you need to write, you need to write 2, and then you need to write sine and cosine. But the angle that you are supposed to put in front of sine and cosine are this number divided by this angle divided by 2. So this becomes 2 theta, and then this becomes 2 theta. That's also possible. Okay? I'm not saying that this is you have to do this, but you need to understand these patterns, because usually if I have sine 4 theta, I don't want to write it more complicated. But sometimes you have the complicated expression. If you can detect the pattern, you can write it in a simplified version. Okay, so that's the main point. But anyway, you need to understand that. For example, if I insist to make sine theta harder, I can, using this formula. For example, I can write 2 sine and then cosine. What should I put here and there? Yes? Yeah, divided by 2, thank you. So it becomes theta over 2, theta over 2. I'm not saying this is reasonable to make something simpler more complicated, but I want you to understand this is a true equality based on that formula. So when you want to understand the formula, don't think that the formula only works when this is 2. No. So you can say that sine of a box, whatever is inside the box, is equal to 2 sine of that box divided by 2, cosine of that box divided by 2. So that is also the correct interpretation of that formula. And I want to draw your attention to this combination in trigonometry. So this combination in trigonometry is also famous. So if you have multiplication of sine and cosine of the same angle, you can write it as 1/2 sine 2 theta. By the way, all of them are the same formulas. What I am doing as the teacher, I am just drawing your attention to it. Yes? So you see, this is the same formula. I have divided everything by 2. So the right-hand side becomes sine cosine. The left-hand side becomes 1/2 sine 2 theta. But what is my intention? My intention is that to train your eyes to catch this pattern. So this sine theta, cosine theta combination is sometimes appearing in trigonometry, and it is very useful to remind yourself about this formula. For example, exactly like this pattern that I told you before. So this pattern appears a lot of times in trigonometry, and we know that this pattern is 1. For example, can you tell me, by the way, what is this one? I want to make sure that you understand everything. So sine to the power of 2 theta plus cosine to the power of 2 theta. So what's the answer to this? Do you need the new lesson to answer this question? Because you might say that, okay, I didn't know the formula for sine 2 theta before. Do you really need the new formula or not? No, because that is this pattern. Okay, so it doesn't matter what you put. What matters is that whatever you put in front of sine, you put the same thing in front of cosine, and then the answer becomes just 1. So it really doesn't need the new lesson to answer that. Yes, I want you to understand these things. So anyway, this pattern is also something important. This combination of sine multiplied by cosine can be written as 1/2 sine of the double angle. For example, if I ask you to calculate this is very useful, by the way. For example, in the exam, even in the national exam, might be they ask you to find the exact value of this, and they give you this question in that part that you're not allowed to use the calculator. Okay, so then how can I understand that? One way, of course, which is the harder way, is to use these formulas to calculate sine of 15 and cosine of 15. How? For example, for 15, do you remember we had this before? I can write 45 minus 30. And then sine of 15 can be used using this formula. Cosine of 15 can be used, can be calculated using this formula, but it becomes very long. But if you remind yourself about this combination that I told you is famous, then you immediately realize that you can use this double formula. Only this version of the formula is in the formula sheet. So if you need, you should be able to interpret in case you need them. Okay? So what is the answer to this, for example? I see multiplication of sine and cosine. I remind myself of that formula. So I would say 1/2 sine of 2 times this angle. Yes, 2 times this angle. The 2 times this angle is also a famous angle, which is 30 degrees. And then you can use the table formula sheet. It becomes 1/2. You also have another 1/2 here. So the answer, it becomes 1/4. So that is the fastest way to calculate this combination. Yes, but if I ask you sine of 15 only, then you have to use this formula, for example. Yes? Any questions? Okay, so that is one formula we discovered. This is called the double angle formula for sine. Of course, with the same strategy, using number 3, I can find the double angle formula for cosine. We had this before, but I just refresh your memory about that. So let me just do it here. In number 3, instead of alpha, I put theta. Instead of beta, I put theta. The left-hand side becomes theta plus theta, which is 2 theta. So this becomes cosine of 2 theta. But what happens on the right-hand side? This is cosine theta. This is also cosine theta. If you multiply them, it becomes cosine theta squared. But remember, you see here what happens? There is a negative sign in between, and then I have sine squared theta. Yes? And I want to write, so you see, this is also a pattern. This is the new pattern, because the previous pattern was the sum of these, which is always 1, but we realize there is also another pattern in trigonometry. So if I have, so let me write them in one place so that you can compare them. This is the new lesson, which becomes cosine of whatever you see here, you multiply it by 2. But if you have the sum of these two, then it is always 1. It is good to write them in one place so that you can compare. This is also in the formula sheet, but of course we will have more versions of that. I think in the formula sheet, I have, by the way, I have uploaded the formula sheet, so if you want to see which formulas you need to remember, you can refer to that. But anyway, I think there are 3 versions of that. Even if there is no, this is the only one, it is useful to learn about these things. Sometimes it is important to write everything in terms of cosine. Okay, then what can I do? I can write, so let me write it later. So here, instead of cosine, I just write cosine squared. But minus, instead of sine, I would write 1 minus cosine squared again. And then I have this. So I have copied and pasted this one, but instead of sine squared, using this pattern, I write 1 minus cosine squared. And then what happens if you multiply the minus sign in? It becomes positive cosine squared plus cosine squared. It becomes 2 cosine squared theta, and then you have minus 1. So this is another way of writing the same thing. But here, this depends on a mixture of sine and cosine. But here, this is only written in terms of cosine. I can do it the other way around. I can get rid of cosine in favor of sine. So I will keep sine squared here. And then instead of cosine squared, I write 1 minus sine squared. Which pattern I am using? Again, I am using this pattern. But what happens now? This becomes 1 minus 2 sine squared theta. Okay, so I will write another version. So there are not 3 formulas. There is one formula, that is the up one, and then you can write it in two more different ways. Okay, so these are called double angle formulas for cosine. So for the case of sine, we have only one version of the formula, but for the case of cosine, you can write it in 3 different, slightly different ways. And again, let me just draw your attention to another pattern. You see, if I ask you what is 1 minus sine squared to sine theta squared, this is the very old pattern we had before. So the answer to this is just simply cosine theta power 2. But now see, if I put a 2 here, yes, another pattern emerges. If you see a factor of 2 here, instead of putting 2 on top, you just put 2 here. It's good to write them in one place to train your eyes to detect these patterns. Yes? Okay, let me solve one example in the book, which is very simple, and then we go to solve some equations that we couldn't solve before. So this is an example I take exactly from the book. So this is also an identity. We want to show that sine 2x divided by cosine to the power of 2x is equal to 2 times tangent of x. We want to show this. So by the way, don't get confused. When I say show, it means this is an identity. You are supposed to start from one side to reach to the other side, but I might give something similar to this and I ask you solve it. In that case, it doesn't mean, it means that this is an equation you are supposed to solve it. Okay? They are very close in nature, okay? But in one case, I ask you to show or prove. In one case, I ask you to solve it. Solve means finding x, so that is an equation. But here, I'm asking you to show this. So you decide to start from one side to go to the other side. For example, let us consider this the left-hand side. Okay, so what is your suggestion? This is one of those examples, even though it's very simple, we couldn't solve it before. Yes? Yeah, that is the double angle formula for sine. So sine of 2x is what? Is 2 times sine x cosine x. Okay, and then what happens? Cosine to power 2 is also cosine x cosine x. You don't need to write it, you can just do it in your head. But this cosine and that cosine are simplified, and then 2 sine x cosine x is what? 2 tangent x, because 2 is just 2, sine over cosine is tangent, and then you reach to the right hand side. But you have to be careful about your heartbeats, yes, because this problem is so hard that you might have a heart attack. Yeah, I don't know what's the problem. Yeah, they're actually underestimating your abilities. These questions sometimes are insulting, aren't they? But anyway, so this is the proof. Any questions? So what you need to do is just to understand, because by the way, if you don't have enough experience, you don't know where to look for in the formula sheet, because I think there are 8 pages. In Math 5, it's 10 pages. So I mean, at least you should have some idea where to look for them, yes? So this means that you shouldn't just randomly look for every possible formula in trigonometry page. You realize that this problem probably will be solved if I use the double angle formula. Then you understand where to look for, yes? Otherwise, it would be a waste of time. Okay, so that's also good. Now let me just ask you to solve an equation. For example, this time I ask you to solve, okay? Solve the following equations. So number 1. For example, sine 2x equals to cosine x. Okay, so this is, I'm emphasizing on the word solve. So it is not the case that I start from one side, do simplifications, reach to the other side. It is probably not possible in this case. But you want to find the suitable value for x so that for those values, the left-hand side is equal to the right-hand side. And you are supposed to find all of them, not just part of them. Yes? Okay. So what I'm supposed to do you have any idea? Again, probably you understand what is supposed to be done, yes? This is the double angle formula, so I use it. So this becomes 2 sine x cosine x, and this becomes equals to cosine x. Remember, you see, when I am solving an equation, I always write the left-hand side and the right-hand side together, and I go vertically down. If you want to write an equation horizontally, then you have to put this arrow at each step, okay? If it doesn't matter if I put the arrow here as well, but I want you to understand. Okay, any other idea? So how can I proceed from now? Yes? Okay, how many of you agree with that? Yes? You divide by cosine. But that is a delicate problem. I want you to remember this one now. I am not allowed to divide because you know that you are not allowed to divide by 0. Okay? So, and then you say that, okay, I divide by cosine. It means that you should have a guarantee that cosine is not 0. But you don't have that guarantee yet because you don't know x. Yeah? If you don't know x, so you don't know cosine x. It means it might happen that you are so unlucky that cosine x is also 0. And that is forbidden in that case. And by the way, this is one of those cases we are unlucky, yes? So because cosine x can indeed be equal to 0. Why? Because if cosine x is equal to 0, the left-hand side becomes 0, the right-hand side also becomes 0. So cosine x equals to 0 is actually one solution. If you just simply drop that and write this, you are actually ignoring that possibility. It is not totally wrong, but it is part of the solution, not all the solution, okay? So be careful. This is extremely important. If you want to divide, you have to make sure that is not equal to 0, but this is not possible in this case. So what is the other alternative? And please remember, don't do that, yes? There is one standard way of solving it, which is very similar to what you said, yes? The other side, and factor it out, and then you will have the 0 product rule, okay? So 2 sine x, if you want, I can put these arrows, but I don't need it, okay? So 2 sine x cosine x, and I move this to the other side, minus cosine x. On the right-hand side, I have 0. What is the benefit? Then you can pull cosine x out. Then it becomes 2 sine x minus 1 equals to 0. And then you say that, okay, this is a number which I don't know. This is a number which I don't know, but I know something. The product is supposed to be 0. This is not possible unless at least one of them is equal to 0. So this means that you can conclude that either cosine x is equal to 0 or the other one is equal to 0. The other one equals to 0 means sine x is equal to 1/2. So you see that if you just drop it, you don't get this one, you get only this one, which is half of the problem, not the whole problem. And then, of course, these are very standard ones, and we have done it before. So cosine x is equal to 0. Of course, I can use the formulas. X is equal to plus minus cosine inverse of 0, whatever. But I think for these special cases that you have 0, 1, and minus 1, it is easier to visualize it on the unit circle. I'm saying that this is not a have to. You can follow the formulas, okay? But can you tell me where I am interested in? Cosine x is supposed to be 0, and I know cosine is related to the x coordinate. So I want to have my x coordinate somewhere on the unit circle to be equal to 0. It is only, no, it is 2 places, yes? Either on top here or here. So this angle, let me write it in radians, okay? So this angle is pi over 2. Okay, this angle is also minus pi over 2. But if I, so I don't know, what do you write? I just want to ask you. So what do you write for the first solution? You can write one for this and one for this separately. Okay, so you can write pi over 2 plus a full round, multiples of full rounds, so which is 2n pi. But if you write this, you are only taking care of this top point, but you are ignoring this. So you have to write another formula for this one. For example, minus pi over 2 plus 2n pi again, yes? This is completely correct. If you decide to write this or that, that is okay. But if you are a little bit observant and experienced so far, you know that these two formulas can be combined into one single formula. Instead of starting from here and going one full round every time, I can go half a circle, yes? So instead of adding 2n pi, I can just add n pi. That I can combine them into one formula. So this is the answer. X is equal to pi over 2 plus n times pi. And you mentioned that n belongs to 0. That is a group of solutions that you would have ignored or you had suppressed if you didn't know, if you just blindly divide by. And then the other one, we have to use the formula, because I told you that this kind of reasoning is usually useful if you have 0, 1, or minus 1. For this one, I have to use the formula. So do you remember? So you have to visualize the formulas, or you have it in your memory, use it. So there are two possibilities. Either x is equal to sine inverse of 1/2 plus 2n pi, yes, and then or x is equal to, you remember, pi minus sine inverse of 1 over 2 plus 2m pi, for example. And I hope that you remember these are famous numbers so that you can refer to the formula sheet. Sine inverse of 1 over 2, you can see it in the table, it is 30 degrees. But I have decided to write the answer in radians, so this means that x is equal to pi over 6. Pi over 6 is 30 degrees, plus 2n pi. Yes? And this one, yeah, let us do it in our head. This is just pi over 6 again. Pi minus pi over 6 is 5 pi over 6 plus 2m pi. Okay, so m also belongs to c. Yes? So there are 3, but how many points are there if you want to visualize it? So you see 2 points are here and there. 1 point is here and 1 point is here. These 2 points are being taken care of one single formula here. And then I have pi over 6 plus 2n pi, which is 30 degrees somehow here. And the other one is 5 pi over 6, which is the other one is here. So it means that there are 4 possible points on the unit circle that correspond to the solution of this equation. Okay, one question. Could I ask you this question before talking about the sign of the double angle formula? Before teaching you the double angle formula for sine, could I ask you to solve this equation? And if yes, how? The reason that I'm asking these questions is because I want to refresh your memory about the points that I mentioned during the lesson. So, do you know how to solve it if I insist you not to use this? Yes?
Would you translate one of them to the other?
Yes? Okay, yes, that's what I want you to know, yes? Because you want to, because you remember, I don't know how much you remember, so sine of a box, I told you, and I wrote the formulas for you. If I know equality of two sines, then I know how to answer it. So this box is what? Is this circle, but plus 2n pi, or this box is pi minus the circle plus 2m pi, yes? We had this in our previous lessons. So if I have equality of two sines, I can use it and solve it. And then if you have this in mind, and then you have that important rule in mind that I can switch between cosine and sine easily by using the complementary angle, then I can do that, okay? So let us just do it. So then what happens? You can solve it in that way. So sine 2x, instead of cosine x, what can I write? I can write sine of its complement, which is pi over 2 minus x. This is another name for cosine. What was the motive behind that? Because now I can use this rule that I know. For example, I can give the role of the box to 2x, and I can give the role of the circle to this. Let us solve it, because it might be it is instructive to compare our answers. So this means that 2x, according to this rule, is equal to the circle, which is pi over 2 minus x, plus 2n pi. Yes? And then I move x to the other side. It becomes 3x, and I divide by 3. It becomes x. If I divide this by 3, it becomes pi over 6. If I divide this by 3, it becomes 2n pi over 3. And then n belongs to z. Yes? And then the other scenario is what? It's 2x, which is this box, pi minus the circle, pi, minus the circle, which becomes minus pi over 2, but minus the whole circle, it becomes positive x, and then I add 2m pi to it. Okay, so I move x to the other side, it becomes x, pi minus pi over 2 is pi over 2, and then plus 2m pi. And now I think we are in trouble, aren't we? Because apparently the solutions are not the same as before. But if something like this happens, then mathematics completely collapses, yes. Because mathematics cannot tolerate even one single slight inconsistency. Either I am doing something wrong, or the answers should be the same. Okay, I can guarantee that I didn't do anything wrong. But why the answers are different? Because you see that, first of all, how many groups of answer I got there? One group and 2, 3, yes? But I realized these three groups in total corresponds to how many points? 4 points, yes? So there are 4 points coming from that. And then you see that there is apparently a big difference, yes? Even if pi over 2, I see it here and there, but here I have any multiple of pi, but here I have only even multiple of pi's, even multiples of pi. But here, pi over 6, yes, good, I have something like that. But then it is 2n pi divided by 3. 2 pi, so n 2 pi divided by 3, this is 120. So that's a multiple of 120, yes? Because pi is equivalent to 180, divided by 360, multiplied by 2 is 120. So it's a multiple of 20, 120. Okay? So what is your answer to this? Is there any inconsistency? This might be an apparent inconsistency. But if you think that this is serious, then it means this is the end of our lesson, so we have to say goodbye, forget about mathematics, try to do something else. Yes? And I hope that you wish this is inconsistent, yes? Because you can get rid of mathematics. So do you see what's the point? Yes?
You see that you have to multiply by 3?
No, you cannot. If you multiply by 3, you have to also multiply x by 3. You cannot just simply multiply one side by 3, yes? So that's what I told you, that what matters at the end. By the way, even before solving it, if you ask me, could you combine how many groups of solutions I have 2. In the previous one, I have 3 groups. If you ask me, Barbara, can you group them into 2 groups? Probably I couldn't understand it myself in the beginning. So it was a wiser way to group these to group these 3 into 2 groups. But let me say that these 2 will generate exactly the 4 points. Why is that? So this one, can you tell me which point of those points is taken care of by this formula? Which one of those 4 points is taken care of with this formula? Or how many of them? Only top one, yes? Because this is pi over 2, which is here. And then this is 2m, which is even pi. So this means that I have to go 1 full round every time. So this I will return back to the same point. So this formula only takes care of one single point, and that is this point. So far so good. At least there is no inconsistency compared to that formula. But what about 3 other points? So this means that this left one should take care of all these 3. But can you see that this is the case? Because if I choose n equals to 0, for example, pi over 6 is exactly this point. Do you remember? But when I start increasing n, I am going 120 degrees at a time. So if I add 120 degrees to 30, I will end up with this one, which is 150. And then I add 120 degrees again, I will end up at 270. And if I add 120, I will reach back to this one. So apparently, there is an apparent inconsistency, but whatever matters is that these 2 formulas together will generate exactly the same 4 points, but these 3 formulas together will generate exactly the 4 points. Yes? So that is also, so I mean, that is important. If you solve a mathematics problem in 2 different legal way, mathematically legal, then the answers should be exactly the same at the end. Okay, but remember, let me ask you a question again. If I just put a 2 here, if I ask you the same question, I don't want to solve it, so this is why I want to write with blue. I ask you this question, you can solve it at home. If you have questions, please let me know. If I just put a 2 here, which method will it still we can continue? Do you think I can solve this problem using this idea anymore? Yes or no? So it means that you decide to switch this to sine. What happens? This becomes 2, and then you write sine pi over 2 minus x, as before. But can I continue more? No, because the formula only works if these coefficients are 1. So this is the end of that method. Okay? So this is important. Mathematics is really unforgivable. So it means that you have to follow exact and precise rules. So if this is 1, you cannot cook up. You can, of course, if you are creative and smart, you can find another way if you want to find the formula for this case. But I want you to understand, you cannot use this formula, which is designed for 1 here and there, to solve this one. Yes? But can I use the previous method to solve this problem? Still yes. Because what you need to do, you need to write 2 sine x cosine x. And then on the right-hand side, you have 2 cosine x. Yes? And still I can solve it. What is the method? Can I divide by 2 cosine x? Yes or no? No. Okay, it's tempting, but say no, because you will actually lose one part. So it means that you pull it to the left and take the factorization. So it's still, so that was a coincidence that I didn't need this formula. But if I change the problem slightly, then you have to use the double angle formula. Okay, so that's it. Let me solve another problem from the book. So let me write number 3. Okay, so let me write it here. So this is the problem in the book. It's a good problem, by the way. So cosine 2x is equal to cosine x minus 2 sine squared times 2 sine x squared. We want to solve this equation. Did I clean the phone? No, you have it on the board still. I hope that you don't need it, so let me just clean whatever we don't need. So let me just start cleaning here. Okay. What is your opinion about solving this equation? So let me rewrite it on top here. So number 3, cosine 2x is equal to cosine x minus 2. Yeah, but by the way, this is not a good problem. I mark because it's so simple again. Yeah, I didn't realize that. Okay, so can you tell me what to do now? First of all, because remember, by the way, in May, you more or less forgot everything, so you need to understand it in this way, otherwise there is no hope for you to be able to solve the problem. So this will indicate you to use one of the formulas. Which formula is suitable for this problem? Yes?
A1 minus 2.
Yeah, because you see 2x, so it reminds you in May. Think in May. You are in the now. This is May 2023, and you have the national exam. Yes, so your memory is actually perished a little bit, or very. But here, cosine 2x indicates you that this is the double angle. So you're not allowed to forget totally about double angle formula name. But if you have understood that and then you realize that is a double angle formula, then you understand where to look for. So you just immediately go to the formulas. And then suddenly another problem comes in. For cosine 2 theta, you have 3 versions, not 3 formulas. They are the same formulas but written in a slightly different way. Which one is suitable? Of course, you can do trial and error, but that is not efficient. So which one do you choose? Because you decided to put something instead of cosine 2x using the double angle formula, there are 3 versions still on the board. Yes, you see there? They are here. So which one, the first one, the second one, or the third one, is most suitable for this? Yes? The third one, yes, because this indicates what to do, yes? Because here, you write 1 minus 2 sine squared, yes, is equal to cosine x minus what? 2 sine squared x. Yes? Okay, answer this question. Can I take these two? Yes or no? Yes or no? Yes? 100%? Yes, this is not the same story. Yes, you can. Yes, because you might say that how should I know this is 0? I don't care. Yes, because when I care, when I am dividing, I care. But why should I care? I move this to the other side. So there are 2 types of cancellation. The cancellation that gives rise to 0, the cancellation that gives rise to 1. The cancellation that gives rise to 0 is of this nature. The cancellation that gives rise to 1 is of this nature. This is important, that this denominator shouldn't be 0. I don't care here. So what happens is that this is 1 now, and then cosine x. This is a very simple equation, actually. How can I solve this? I told you that when it comes 0, 1, and minus 1, even though you can use the formulas, it is better to visualize it using this. So cosine x should be 1. So it means the x coordinate should be 1. There is only one single point, yes? And that is this point. The corresponding angle is 0. Okay, but is 0 the only one? No, because I can go full rounds, yes? So this means that x is what? 0 plus 2n pi. And I don't need to bother to write 0, yes? So this x becomes 2n pi. And then n belongs to z. Yes? So that is also a problem here. Let me also solve this problem. It is also from the book. So what do you think about this, number 4? Sine x cosine x is equal to 1 over 4. So how can I solve this equation? I think you can see the formulas you need on the board. So let me bring it a little bit lower. By the way, if you, okay, before me guiding you, can you tell me which of those things? Because you remember, I told you, remember, this combination is famous in trigonometry. When you have the product of sine and cosine of the same angle, you need, this is apparently not related to the double angle formula. But because if you have this in your memory that this combination appeared for the first time in this lesson, then you realize that this combination is here, yes? So instead of sine cosine, what can you write? By the way, the book has done it differently. The book has multiplied by 2. It becomes 2 sine x cosine x. That's also completely valid. The reason that the book is motivated to multiply it by 2, because for the book, this combination is famous. 2 sine x cosine x, yes? And then if you multiply by 2, it becomes 2 sine x cosine x. The right-hand side becomes 1/2. That's also good. So let's just follow it there, okay? This becomes 2 sine x cosine x, and then it becomes 1/2. But then you need to collect it in the form of sine of 2x equals to 1/2. But this is doable. Why? Because you can give the roll of the box to 2x. And then what happens? The box, which is 2x, is equal to sine inverse of this number plus 2n pi, or 2x is equal to pi minus sine inverse of that number plus 2m pi. Okay? So this is a famous angle. I've decided to write in radians, so this is just pi over 6, 30 degrees. But I want to find x, so I have to divide by 2. When I divide by 2, pi over 6 now becomes pi over 12. 2n pi becomes simply n pi. N belongs to z. So that is one part of the solution. Another part is here. So what is this number? This was pi over 6. Pi minus pi over 6 is 5 pi over 6. And then you divide by 2. So x becomes 5 pi over 12 when you divide this by 2. And you also have to divide this by 2, which becomes m pi. And then m belongs to z. So we have 2 groups of solutions for this equation. Any questions? Okay, so I think this section is also finalized. So the lesson is up to in the beginning of section 2.3. The rest of it is more or less simple. So it's graphing, yeah, just a little bit knowing about the graph of sine, cosine. They are important, but there's nothing very deep into them. So, any questions? Okay, I will update the Google Classroom. If you want, you can work on your own. And by the way, one thing is very important. Because in the previous video, some of your heads were actually shown in the video when you stand up before when I close it. Okay, and I don't know, it is 4 days that YouTube is processing it because I want to censor that part. But of course, this is the back of your head. I don't think people can realize you. But anyway, we were not comfortable, so I'm taking it out. The reason that I have delayed for publishing that video in number theory or whatever it was, okay, no, sequences, is because I don't know, it's 4 days that the YouTube is processing. As soon as it is ready, if it is going to be ready ever, then I will actually publish it.
Okay, so please wait so that I stop recording and then stand up. Okay, but not today, of course. We have enough time. You can practice on your own.